Hello everyone, let's look at Leetcode question 1701, average wait time. So in this question we're given a two-dimensional array called customers, and the individual values of customers at I is the arrival and time. The arrival time of the ith customers are sorted in non-decreasing order, and the time is the time needed to prepare the order of the customer. Note that we're given only one chef to complete every order, so there must be an overlap between waiting times and starting times of every customer's order. We need to return the average waiting time of all the customers. So how do we do this? Well, before we look at the examples, let's look at the constraints. There must be at least one customer and one arrival time and preparation time for each customer array. And the arrival time of one customer must be less than or equal to the arrival of the next. Okay, so let's look at the examples. Okay, so as provided in the first example, we have the two-dimensional array customers, where each attribute of customers contains the start, arrival, and the time required to prepare the customer's order. So the first customer is starting at time 1. And it takes 2 to prepare his meal. So the chef will not be available until time 3, and so the next customer arrives at 2, but will have to wait an additional 1 before his order is being prepared, because there's an overlap and there's only one chef. The 5 is still the same, it takes 5 to prepare, plus the 1, there's a total of 6 for wait time of the second customer. And if you look at the last customer, the same here applies, but this customer arrives at time 4 and will have to wait 4 before the chef is available, because the chef must prepare this large order of 5 and is available at time 8. The 3 for the time is the preparation time, and it's the same. So it's 3 plus the additional 4, so customer number 3 will have to wait 7. And now, to calculate the total wait time, we have 2 plus 6 plus 7. This is 15, and since there were 3 customers, the average wait time is 5. Now in this example, the same applies. The customer number 1 starts at 5, and it takes 2 to prepare. However, the second customer also comes in at time 5 and must wait 2 before the chef is available, and then the preparation was 4, so 4 plus 2 is 6. 6 for the wait time of customer 2. Then the third customer arrives at time 10, and the chef is not available until time 11, so this customer waits an additional 1, so a total of 4. And finally, we have an idle customer here that arrives much later with no one else at the restaurant, and it just takes 1 to finish his order. So then the total wait time would be 2 plus 6 plus 4 plus 1. Average wait time is 13, divided by the total customers 4. That is 3.25. So first we initialize the variables total wait and current wait to 0. Next we can loop through the customers, and each customer is represented by their arrival time and their prep time. The current wait is updated to the maximum of arrival time and the current wait. This checks if the chef is already busy with the customer arrives. So if a customer has arrived and the chef is busy, then the current wait will not be arrival time, but current wait itself. However, if the chef is not busy, then the arrival time will be the current wait, because the chef will immediately start working on your order, and the starting value of your wait will be this current wait. So then we can update the current wait value to be current wait plus prep time, and it's incremented by prep time of the current customer, so that the time they need to wait and the prep time is combined. Then the wait time is calculated by subtracting the arrival time from the current wait. This gives us the total wait time of one customer, and then we can accumulate it to the total wait. Once we have looped through every customer, we can calculate the total wait divided by the length of customers to give us the average. And as you can see, this solution works. So the time complexity is O of n, where n is the length of the input list customers. And this is because the code involves a single loop and iterates through each customer exactly once, and it's performing constant amount of work. The space complexity is O of 1. Besides the input list customers, only a fixed number of integer variables are used for calculations, and they don't depend on the size of the input and the scale with the input. So regardless of the number of customers, the space used is always constant. And that's it for this video. Thank you, and see you next time.